Hello students, in this video let us discuss about finding the adjoint of a square matrix. Now what do you mean by adjoint of a square matrix? For which we should know the cofactor matrix. So first we have to find the cofactor matrix, then you take the transpose of a cofactor matrix, then the transpose of a cofactor matrix is called adjoint of a matrix. So see how we have written in the next line, adjoint of a matrix A. The symbol that we use is ADJ. That means it is adjoint of A, that is equal to transpose of a cofactor matrix A. So before going to the adjoint of a square matrix, let us know how to find the. So here let us see how to find the cofactor matrix. So first let the given matrix be A is equal to, this is a matrix A. Let us write this as the elements as A11, A12, A13, A21, A22, A23, A31, A32 and A33. Okay, this is a given matrix. So now we will write its cofactor matrix. Cofactor matrix, just by changing the symbol, we will write it as a capital. Say for example, cofactor matrix. This can be written as cofactor matrix. We represent the same way but with the capital symbol. So we write this as A11, A12, A13, same way A21, A22, A23, A31, A32 and A33. So this is how we represent the cofactor matrix. Now how to find the elements of this, how to find this cofactors? So we have a general formula to find the cofactor. It's very important, you should remember this. So formula to find cofactors. Okay, so in general the formula is Aij. Okay, Aij, we will write it like this, the general form. Let me explain this. That is minus 1 to the power, what you have here is I and j, right? So this is I plus j into minor of Aij in determinant A. Okay, so now let me write the determinant A like this. Determinant A as A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, this is how we write. Now how to find the cofactor? Let me explain this in the next slide. Let me find some of the cofactors. So in the same way you can continue. Okay, so now you should remember the cofactor matrix. Okay, we represent this with the capital sign, capital symbol. So now how to find A11? A11 is equal to, see, Ij means here I is 1, j is 1. Okay, so both are same. So what is the formula? Minus 1 to the power 1 plus 1 into minor of the matrix. Now here what we should do is, if you want, let me write it here again. The determinant, This is just for your reference so that this will be available here. Okay. This is A11, A12, A13, A21, A22, A23, A31, A32, A33. Now you know the formula for finding the cofactor, minus 1 to the power I plus j. That is, in this case it is 1 plus 1 into the minor of Aij, minor of A11. So how to find the minor of A11? See here, we want to find now the minor of A11. So A11 is this one. This is A11, correct? So we want to find the minor. Its minor is this one. Okay, you have to exclude the row containing A11 and the column containing A11. So excluding that, you see what are the other four elements, that is A22, A23, A32, A33. So here what you have to write is the minor of A11 as determinant A22, A23, A32, A33. Okay, so this is how we write it. So this is a determinant. So you know how to solve this determinant. In the problem we will do that. Now if you want to find the next one, that is A12. How to do this? A12. Now I is 1, j is 2 here. So minus 1 to the power 1 plus 2 into its minor. Now you see, I'll represent this with the different color for your reference. Now you see here, we want to find the minor of A12, right? See, this is A12. Now you have to exclude this and exclude this. So what is remaining? A21, A31, this side A23, A33. Now you can solve this. Okay, in the same way, if you want to find the one more, that is A13. A13 is minus 1 to the power 1 plus 3 into minor of A13. Now you see minor of A13. Let me use another color for reference. Now you have here A13. A13 is here. Okay, now you have to exclude that row and this column. So what is remaining here is A13. This is A21, A31 into A22, A32. Okay, so like this it goes. One more let me write, so then you can generalize it. Okay, so if I want to write for A21, this is minus 1 to the power 2 plus 1 into minor of A21. Minor of A21 is, you have to exclude the column containing A21 and the row containing A21. So what are you getting? A12, A32. Here A13, A33. Okay. and so on. You can write for each of the cofactor in the same way. Okay, so I hope you understood how to find the cofactor. So what has to be done next? Let's work out one problem. So in that it will be very clear to you how to find the cofactor of a given matrix and then find the adjoint of a given matrix. Okay, so let me write one question here. Question: find the adjoint of the matrix A, that is equal to 1 1 1 1 2 minus 3 2 minus 1 3. Okay, so this is the given matrix. So this is of the form. Okay, now how to solve this? Now this is of the form. You should always compare this with the standard form. So solution, this is of the form. The given matrix is of the form. What is it? Is of the form. In general, how do we write? A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, this is the standard form. Now, what would be its cofactor? Cofactor matrix. How do we write cofactor matrix? Cofactor matrix is the same type, but here we need to use the capital symbols. A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, so this is the cofactor matrix. Let us call this as equation 1. What is the next job? Next job is to find each of the cofactors. So what is the formula for finding the cofactor? So you have to write the formula because formula carry marks. Formula to find cofactor. What is the general formula? Formula to find the cofactor matrix: Aij is equal to minus 1 to the power I plus j into minor of Aij in the given matrix. Okay, so in the next slide we will find each of the cofactors. So how many cofactors? There will be 9 cofactors. So let us find all those 9 cofactors. You should have a book ready with you with the values of the matrix written. Otherwise you'll have a mismatch, because you should know that. So how to find A11? So A11 is minus 1 to the power. So what is here? A11 means it is I is 1, j is 1. So minus 1 to the power I plus j. So you get it as, what is this? 1 plus 1. This is 1 plus 1 into, directly let me write the minor. So you should have a paper ready with you which has the matrix. So this will be 2 minus 3 minus 1 3. Okay, so that is minus 1 to the power 2 into, so how will you find the value of the matrix? You know that this is 2 into 3 minus of this one. So first you have to do this, next you have to do this operation. Okay, so I'll write it here, 2 into 3 minus of minus 1 into minus 3. So when you solve this, you get this as, see, minus 1 to the power 2. Minus 1 to the power some even value, that is 2, 4, 6 is always plus 1. Minus 1 to the power odd values, say for example 3, 5, 7, 9. So all those will be minus 1. So here it is minus 1 to the power 2. So that is 1 into, this is 6 minus 3, that is equal to 3. So we got A11 as 3. In the same way, we'll have to find each of the cofactors. So A12 is minus 1 to the power 1 plus 2 into the minor, that is 1 minus 3, 2, 3. Okay, so this is minus 1 to the power 3. So minus 1 to the power 3 is how much? Minus 1. Okay, into 1 into 3 minus 2 into minus 3, that is equal to minus 1 into 3. So minus 2 into minus 3 is, minus into minus is plus, right? So 3 plus 6, so you get this as minus 9. Similarly, A13. So A13 is minus 1 to the power 1 plus 3 into, what is the minor there in the main matrix? 1, 2, 2, minus 1. That is minus 1 to the power 4 into 1 into minus 1 minus 2 into 2. Okay, 2 into 2. So this will be 1 into minus 1 minus 4, that is equal to minus 5. Same way we have A21. Okay, so first row is over. Now next one is A21. So A21 is minus 1 to the power 2 plus 1 into the minor there, that is 1, 1, minus 1, 3. That is minus 1 to the power 3 into 1 into 3 minus of minus 1 into 1, that is minus 1 into 3 plus 1, that is minus 4. So next is A22. So minus 1 to the power 2 plus 2 into minor in the main matrix 1, 1, 2, 3. That is minus 1 to the power 4 into 1 into 3 minus 2 into 1. That is 1 into 3 minus 2. That is 1. Same way, we'll go for the next, that is A23. A23 is minus 1 to the power 2 plus 3 into the minor 1, 1, 2, minus 1. So that is minus 1 to the power 5 into minus 1 to the power 5 into 1 into minus 1 minus 2 into 1. So this becomes minus 1 into minus 1 minus 2, that is 3. Now 3 more cofactors we have to find, that is A31 is equal to minus 1 to the power 3 plus 1 into the minor there, that is 1, 1, 2, minus 3. So that is minus 1 to the power 4 into 1 into minus 3 minus 2 into 1. That is 1 into minus 3 minus 2, that is equal to minus 5. Then A32 is equal to minus 1 to the power 3 plus 2 into minor 1, 1, 1 minus 3, that is minus 1 to the power 5 into 1 into minus 3 minus 1 into 1, that is minus 1 into minus 3 minus 1, that is 4, that is 4. Then the last cofactor, that is A33, that is minus 1 to the power 3 plus 3 into the minor 1, 1, 1, 2, that is minus 1 to the power 6 into 1 into 2 minus 1 into 1, that is 1 into 2 minus 1, that is equal to 1. So we have found out all the cofactors. Therefore, in the next slide, let me write the cofactor matrix. So from equation 1, the cofactor matrix becomes, that is, you substitute the values of the cofactors, so we get it as 3 minus 9 minus 5 minus 4 1 3 minus 5 4 1. Okay, so now how to find the adjoint of a matrix? Adjoint of matrix A is equal to transpose of cofactor matrix. So we have the cofactor matrix above. Now you have to take the transpose. So when you take the transpose, you know how to take the transpose. The first row becomes the first column here. So that is 3 minus 9 minus 5 minus 4 1 3 minus 5 4 1. Okay, so this is the answer. So while looking at the video, you should have the main problem. So main, in the sense, you should write it in the book. The paper should be with you. Only then you will be able to follow up. Otherwise, you will not be in a position to understand the minors and the positions of the A11, A12, etc. So you should have a readily available with you the problem. Okay. So now I think this would be sufficient in this video. So next video, let me post one more type of the problem similar to the adjoint of the matrix. So thank you.